All right, this is AP BC Calculus. We're doing a BC only section. This is Unit 10, Section 5, Harmonic Series and P-Series. So in the last video, which was the integral test, I mentioned that the integral test is not normally near the top of my checklist. These absolutely need to be the top of your checklist. So there are certain series that we're going to memorize, very specific series. We talked about geometric series in 10.2, and that was really important. Harmonic and P-series are super duper key. You're going to see them over and over again, and you just want to know, looking at them instantly, if they converge or diverge. We're also going to have two other important videos coming up, 10.7, which is the alternating series test, and 10.8, which is the ratio test, and it's super huge. So if you're trying to prioritize the stuff that really matters in these videos, this is an important video. So let's talk about a P-series. So a P-series is any series of the form 1 over n to the p, where n usually starts at 1, but could honestly start at a later value, and I'll talk about that in a sec. So a P-series converges for p-values greater than 1, and a P-series diverges for any p-value less than or equal to 1 every single time. Now, a couple things about a P-series. The reason I said that it could start, so it doesn't have to start at 1, right? So this could start later, right? It wouldn't matter, because if you have the sum from n is, let's say, 10 to infinity, losing those first 9 terms doesn't make a difference, right? So this behaves the same as the sum from n is 1 to infinity of that same series, right? Because the first 9 terms don't make a difference in whether this is finite or infinite, right? Those first 9 terms are finite by default. They are finite terms. So those 9 finite terms, or however many you ended up, if you started at n is 50, right? Doesn't matter. Those finite terms don't make a difference in whether the series converges or diverges. They don't make a difference, those terms at the beginning. Similarly, right, this doesn't have to be a 1, right? If this were a 3 over n to the p, this behaves the same as a 1 over an n to the p, right? And the reason I say that is because I could factor this 3 out, right? And this would just be 3 times this series, right? And since we're not trying to find a value for the series, right, if this is finite, right? If it's finite, then 3 times a finite number is also finite, right? It's also going to converge, right? If this thing were infinite, right? If this thing is diverging, well, 3 times an infinite quantity is also infinite. So it doesn't matter it doesn't matter that you put a number on top. The idea is that we really care about that n to the p, right? And we care what value p is. All right, so let's walk through some. So for each P-series below, determine if it converges or diverges. All we really care about is the P in this situation. Remember, it's a P-series if you have essentially some constant over an n to a power, right? That's what makes it a P-series. From n is who cares to infinity, right? So like it doesn't really matter what the n is. Now all of these start at n is 1, but so all of these are P-series. They all have a constant on top of an n to a power, right? So all I care about is P. Well, in this situation, P is 3. Remember that a P-series converges if P is greater than 1 and diverges if P is less than or equal to 1, right? So since 3 is bigger than 1, the answer is this thing converges. That's it. You don't have to put logic there. You're allowed to just memorize, hey, this thing converges. Same thing here. P is 2. 2 is greater than 1. This thing converges. It's expected that you will just memorize the convergence and divergence of a P-series. Now this is actually an n to the 1/2, and 1/2, so P is 1/2, which is less than or equal to 1, right? So this thing diverges. Okay, and again, it doesn't matter that it's a negative. It just means that it's going to diverge to an infinitely negative sum instead of an infinitely positive sum. That's all. Doesn't matter. All right. Same thing. Give P1 a try. So again, you're only really looking at P, right? The P is 5. 5 is greater than 1, so this thing converges. Right? And again, it's a good idea to have in your brain that this is what happens with convergence and divergence. Now, this one, right? So this is actually an n to the 3/2, right? Meaning that P is 3/2. Well, 3/2 is greater than 1, so this thing also converges, right? And then this one, this is actually an n to the 1st. So P is 1. 1 is greater than, or sorry, less than or equal to 1. Come on, brain. Which means this thing diverges, right? And we're actually going to talk about this series in just a sec, the 3 over n, or just a 1 over n in general, because that's important. All right, so the harmonic series is the P series where P is 1. So 1 over n, the one that we just kind of saw here, except it was a 3 over n, this is called the harmonic series. You want to memorize its name, and you want to memorize it diverges. Please, please, please memorize this diverges. So this is called the harmonic series, so 1 over n, so 1 over 1, 1 over 2, 1 over 3, 1 over 4, and it diverges. The alternating harmonic series, where I put this thing in the front, right, this is what makes it alternating, right, so this alternates signs, and you can see that, where it's positive, negative, positive, negative. It can either be this, or it could be the one that starts negative. It doesn't matter if it starts negative, right? If we did this one, if we started with this, it would start negative and then positive. It doesn't matter which of the two we end up with. These alternating series, the alternating harmonic series converges. We're going to learn why when we get to 10.7, but just trust me, you want to memorize in your brain that the harmonic series diverges and the alternating series, harmonic series converges. Please, 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 it's going to come up. All right, that is it for 10.5.